Hi friends, in this video we're going to talk about an overview of web APIs and basic API security measures. The whole content of this video is present in this blog post, so please check out the link of this blog post in the description of this video. Alright, what's an API? API is a way two applications can talk to each other. Just like two people can talk to each other with a language, API is something like a set of rules. Using those rules, two applications can talk to each other. So formally, you can say that API is a specification that defines the request and response formats on how a client can call a server. And why use API? One of the reasons why APIs are used is that APIs can be used to create modular systems. Here there are multiple components in an application, and these components are exposing some API, and the main application can use these APIs to deliver the required functionality. But in terms of development, you can have a development team for account service, inventory service, shipping service, and they can operate in isolation. They just have to implement the API specification, which is designed by the management. So using APIs, you can create modular systems where multiple teams can operate on a single project. And one more reason why people can use APIs is information hiding. Suppose you have a system which fetches and provides some data to a client. The client need not bother how the API is implemented. He just calls the API and gets the response. The information on how the API is implemented need not be known to the client. That means the API can be implemented in Java or Python, the database can be Postgres, Oracle, or the data can be fetched using some other credentials. The client need not to know that. So one more major factor to use APIs is information hiding. And another main use case of APIs may be extending an existing application. Let us think you already have an existing application. And if you develop an API for that, using that API, some other developers can use the functionality of the application and create another application. So an extension of the application can be developed using the API of this application. And this way, multiple developers can use the APIs exposed by the application and create new features. So this way, if you create APIs around existing applications, you can extend that application. So this is another use case of using APIs, which is extending applications. Alright, let's see a very simple API example. Let us think I have created a server which can multiply two numbers. So it has exposed an API where you give a URL and you say slash multiply the first number and the second number. Then it will send a response of the product. So if you change these numbers, instead of 5, 8, if you say 2, 5, you can get a product of 10 here. So the client is just calling the API and the server is doing the work and providing the result to the client. The same way, it can be a post request also, where the client will provide the inputs in the post request body and the response would come in the result from the server. So this is a very simple basic API example, which is a get request and a post request. And in the previous two examples, which is a get request and a post request, we have talked about web API. So web API means an API to communicate with the server over web. That means the request from the client to server will be made over HTTP. Let's see a very simple example. So you have a client and it will call the server over a HTTP URL, and the server will provide the response to the client. It can be a JSON, XML, or whatever. So we said that a web API means an API which uses HTTP for communication between server and client. So what is HTTP? So HTTP is a protocol where clients can talk to servers over the web. And in this slide, I'm going to show you a basic overview of HTTP protocol. In the HTTP protocol, the request body would be something like this, where the first thing, this get, would be the HTTP verb or the HTTP method, which can be get, post, put, etc. And this slash is the path. It can be something like slash abcd slash inventory, something like that. And this is the version of the protocol, and this is the headers of the HTTP request, and there can also be a HTTP body. And then the server can give response something like this. Here it will be the version of the HTTP protocol, and this is the status code of the HTTP response. 200 status code means the response is okay. If you get something like a 500 status code, that means it's an internal server error. So there are some status codes which can be easily understood by the clients. The status codes are also mentioned in the specification, and this is the status message. It's just the literal translation of this status code. And then this is the response headers, and obviously there will be a response body below this content. So that's how the HTTP protocol works in a nutshell. And you might have heard a lot about REST API. So REST API is an architectural style that allows clients to communicate with server resources with standard HTTP verbs like get, put, delete, and the response will also accommodate the HTTP status codes, and URL parameters will be used for querying, etc. So basically, before REST API, people used to do everything in the HTTP body. But in REST API, we can use the HTTP protocol to access the server resources. For example, HTTP GET means you're querying. HTTP POST means it's doing some action like creating a new user. And HTTP patch means updating the user, something like that. And in the response, the server need not say the status is okay in the response body. Instead, the server can give a status code 200 and the client can understand that response is okay. And okay, we have talked about the concept of HTTP APIs or web APIs, the clients, servers, the HTTP protocol. But as a developer or a client, how can we call APIs? Well, let's talk about some very common options. There is this tool called Postman, which provides a very easy user interface to communicate with APIs. And there is this tool called REST client in VS Code. If you're using VS Code, you can use this REST client to do API calls. It's very user friendly. And there is this command line utility called curl. So in the command line itself, you can just write a command to call a HTTP API. And if you want to call APIs in your applications or scripts, there will be standard libraries where you can use HTTP clients to call the APIs. For example, in Python, there is request module. In .NET, there is HTTP client class. There is also HTTP client class in Java. There is HTTP module in Go. So major programming languages have standard HTTP clients using which you can call web APIs. By the way, I already created a video on how to create API endpoints with Flask, how to implement OAuth 2.0 client credentials flow in Flask server and Python. I will leave the link of these videos in the description. You can check it out if you are interested. Alright, let's talk about Postman. So a Postman is something like a Chrome or Edge browser where you can do requests to servers. But here you can mention a lot of parameters of the HTTP request. For example, you can mention whether it's a GET request or a POST request, what is the request body, what are the request headers, etc. So it's a very user-friendly tool and you can call APIs without doing any coding. And if you're using Visual Studio, there is this awesome extension called REST Client. And if you install REST Client and create a file, something like index.http or abcd.http, so you can do HTTP request something like a script. And if you send the request, you will get the response from the server. So this is the VS Code REST client extension. Just install this extension and let's create a new file something like index.http, and Visual Studio will use the REST client extension in this file because you get the extension as .http. And to do the demo, I will create a simple Flask server and run this. Okay, the Flask server is running. Let's try to open the .http file. And here let's try to create a simple request. My server is running on localhost port 5000 and there is a URL endpoint called multiply, and here you need to give the HTTP version which is http/1.1, and since I will send a JSON body, I can write content type as application or JSON. And then let's try to give the post request body. Since I'm doing a post request and the post request body is a JSON, so I'm giving the X and Y parameters to multiply. So I can write something like, and if I just send this request, alright, I just did a mistake here. It's http:// and let's try to save this and send this request. Now you got the response where the product is a multiplication of these two. 34 into 3 is 102. And I can do one more request. I can just copy paste this whole thing and I can change the parameters like 4 into 3 or 4 into 5. And after each request, you need to give some 3 hashtags. Then it will be a second request and you just send the request and you got the response. So this way you can create an API document and you can create all your endpoints to test, and you can just take it anywhere and run it anywhere. So REST client is awesome and you can use it as a VS Code extension. Alright, that was about VS Code REST client extension. And to call APIs, you can use some command line utilities present in the operating system, something like curl. So if you write curl google.com or curl your IP address, and if it is listening on HTTP, you'll get a response. Let's see a quick demo. I can write something like curl google.com, you'll get the response. And another way to call APIs is through the libraries in the programming languages. For example, if you use the request module, you can just write request.post and you can do a post request and you can parse the response. In this example, I'm calling the same multiply endpoint and I'm giving the post request as this JSON variable and I'm checking if the response is okay. And if I'm getting the response, I'm parsing the JSON and also parsing the product that is the result of the API. Alright, we talked about how to call APIs from programming languages or through tools. Well, how to create APIs or how to host APIs. Well, we have seen an example already. You can create a web server and create API endpoints like this. The API endpoint will listen on HTTP and it will parse the parameters from the request, do the processing, and provide the output. So this is a simple API server. So this way, by creating a web server and implementing the API specification, you can host the API. Alright, let's talk about some HTTP status codes. When you call an API, if everything is okay, you'll generally get the status code 200. If you send a request which is not relevant, you may get this request 400, which means bad request. Or else if you try to access a URL which is not present, you can get something like not found. Or else if you wanted to access a URL which is not authorized, you may get this 401 unauthorized. So in the HTTP protocol specification, there are a lot of status codes and there is a standard meaning for each status code. Generally, these are the common status codes you will deal with, and there are a lot of status codes, and the status codes would be something like this. If the status code starts with 1, it's like an information status code. If the status code starts with 2, it means the status code is success, but there are some meanings into it. And the status code starts with 300, that means the response is being redirected. If the status code starts with 4, that means the client did something wrong. And if the response status code is something starting with 5, that means 500 or 502 or something like that, that means there was some server error. So these are some of the HTTP response status codes you will deal with while using APIs. Alright, that was about what is an API, how to call an API, what are the tools to call APIs, and how to host APIs. Alright, you hosted your API, but you need to think about security. So I'm going to talk about some basic API security measures here. One thing can be whitelisting. It's really straightforward and very effective. Whitelisting means you only allow the IPs which are intended to access the API. If a non-whitelisted IP tries to access the API, just deny it. So this is called whitelisting. Or else you can give credentials. That means the user, while accessing the API, should provide an API key which is provided by the issuer. For example, here in the JSON request, the user can send a key, something like API key, and give the API key, and the server will validate that API key. So this way you can use credentials to secure your APIs. Another thing you can do is rate limiting. Suppose there is a malicious client who wants to overload your server. You can limit that using rate limiting. You can create some mechanism where you can allow only a certain rate of request from a single user. So that's called rate limiting. That means you can only allow something like 100 API calls per minute or 1000 API calls per hour, something like that. And just like credentials, you can use a central token service which the resource servers or the API hosts will use to validate the API clients. So this is like a central token service where if you have some hundreds of APIs and hundreds of clients, you don't need to register client in every API. You can register the client in a token service, and the token service will issue a token, and the API client will use that token to access the resource server, where the resource server will authorize the API client based upon the token. We'll talk about this in the next slides. These are some basic and obvious ways how you can secure your APIs: whitelisting, credentials, rate limiting, and token service. So let's talk about a token service. So you'll have a central server which is called a secure token service, which registers clients and issues tokens to them. So the client will be registered in this token service, and while accessing the API, the client will call the secure token service, get a token to access the API, and then while requesting the API, it will send the token to it. The API resource server will validate the token, and if the client is authorized, then it will send the response. So using secure token service, you can centralize your client authorization to a secure token service. And this is the specification or the flow. And the authorization procedure we just talked about is called OAuth 2.0 client credentials authorization flow, and it looks something like this. The client will request the token from the STS or the secure token service. It will get the token, and using the token, it will access the API. The API will validate the token, and if the token is okay, then it will send the response. So this is called the client credentials API authorization flow. And if you want to implement client credentials authorization flow in your Flask applications, I've already created a video on that, and I will leave the link of that video in the description. So that's it, guys. We have talked about what is an API, web API, how to access an API, what are the tools to access web APIs, how to host APIs, and how can you do some basic API security measures. You can see I've created a blog post on the overview of web APIs and basic API security measures. The whole content of this video is present in this blog post. So please be sure to check out the link of this blog post in the description of this video. Please ask questions or post your valuable feedback in the comment section. Hope you like this video, guys. Thank you for watching. Peace.